Okay, folks, on page 25, just a very quick recap of types of transmutation. We got natural transmutation and artificial. Here's the difference. In natural transmutation, there's one reactant. In artificial, there are two reactants. Right here, there's one reactant. Gold 198 decays to produce a beta particle and mercury 198. In this artificial transmutation example, we've got beryllium 9 is slammed into by a proton, a hydrogen nuclei, mass of 1, charge of 1. Those two particles slam together. That's because in artificial transmutation, we take a naturally stable substance like beryllium 9, we force it to become unstable by bombarding it with another particle. That would be this proton of this hydrogen 1, hydrogen nuclei, and then it goes through transmutation. So artificial, there have to be two reactants. Natural, there's only one reactant. It's naturally unstable. It goes through transmutation on its own. Okay, so here are some quiz you examples. Is this an example of natural transmutation or artificial transmutation? Look at the number of reactants. Look what is happening. It's artificial. We've got two reactants here, helium and nitrogen. Helium is being slammed into nitrogen to cause transmutation to occur. Is it natural or artificial? Well, there's one reactant, so it's natural transmutation. It must be unstable, goes through transmutation. Natural or artificial? There are two reactants, so it can only be artificial transmutation. Okay, natural or artificial. Here we've got a neutron being slammed into this uranium, and then that forms this unstable nucleus, which breaks apart into some smaller nuclei. This one is artificial because humans are slamming neutrons into the uranium. Natural or artificial? This one has a lot of products. This one is natural. This cobalt is naturally unstable. It decays and it emits a positron and a gamma particle, or emits some gamma radiation. Nuclear fusion. Deuterium and tritium are being slammed together, then fusion happens, and they produce a helium nuclei, and they emit energy and some neutrons. In this case, it's artificial. Both fission and fusion are artificial transmutation, where particles are slammed together. Okay, now we're going to do the check-in, and is this actually a yellow sheet? I'm not sure. Is this? Yeah, this check-in sheet is yellow, so do it, and then let's check it together. Okay, hit pause, and now we're back. Which nuclear decay emission consists only of energy? Well, alpha particles, beta particles. If something's a particle, it's not energy. Positrons, those are anti-electrons. Those are a type of particle. Gamma radiation. Radiation is energy. What's the name of the process in which the nucleus of one element is changed to the nucleus of a different element? That's transmutation, changing one element to another. Which one is spontaneous nuclear decay? We're going to find one that's, okay, neither of these are nuclear decay. Spontaneous nuclear decay, just ignore these little weird boxes. Spontaneous would be one reactant. Okay? This one would be artificial transmutation. Okay? This one is natural transmutation. Okay, number 4. Radiation emitted during radon's decay process is used for cancer therapy. What is the nuclide X formed in the following reaction? Radon goes through natural radioactive decay and emits a helium nucleus or an alpha particle. This is an alpha particle. All right, what's X going to be? Well, the masses on this side have to add up, and the charges on this side have to add up to the same thing that's on this side. So 222 equals 4 plus something, whatever this is. It has a mass of 218, and then it has a charge of 84, or it has 84 protons. So we find element 84 is polonium. PO is element 84. How do I find that? Because I look for something that has 84 protons, so it would have a charge of positive 84. One cobalt radioactive isotope is used to treat cancer. Identify the nuclide X in the reaction below, where cobalt-60 undergoes beta decay. Okay, this one's a little trickier. Okay, the mass is easy. Whatever this is, this plus 0 equals 60. So this particle is going to have a mass of 60. But then 27 on this side has to equal something plus -1. So this, whatever this is, its charge is going to be 28, as weird as that seems. So we find the element with 28 protons, or the element number 28. This is an isotope of nickel. It is nickel 60. Okay, because 60 equals 0 equals 0. 28 plus -1 equals 27. Okay, this. And protactinium is the third rarest of all the naturally occurring elements. What is the decay particle emitted and decay process? Okay, so protactinium turns into actinium and emits some kind of particle. What does X equal? Well, 231 on this side, 227 plus something. I think I know what this is. It's got a mass of 4. 91 equals 89 plus something. Okay, it's got a charge of 2. That has to be an alpha particle. It could also be written like this. It's an alpha particle with a mass of 4 and a charge of plus 2. Okay. All right, and I'm going to pause here, and the next video will take you through fission and fusion.